So far, we've looked at what it means to be acquired from an overhead perspective, and also we've talked a bit about electromagnetic radiation. In this last part of this section, I'd like to look at the distinction between reflected or emitted electromagnetic radiation and what that means for remote sensing. You'll remember from the previous video I said that most of the action in remote sensing is taking place in the visible part of the spectrum, also infrared and microwave parts of the spectrum. And to understand why I said that, let's take a look at the different types of sensors that are commonly employed and how they work. This slide has a lot of information, and let's break it down. There's three parts: visible and reflected infrared remote sensing, thermal infrared remote sensing, and then finally microwave remote sensing. And let's talk about each of those in turn. And in particular, let's talk about these three characteristics. The source of the light, the radiation source, where's that coming from? It's different for each type of remote sensing. The objects that are under observation, what is happening with them? And finally, the type of remote sensing, is it active or is it passive? And then down here, I'll explain this in a second. But first, perhaps the most general type of remote sensing is one in which the sunlight illuminates the landscape. Objects in the landscape reflect part of that sunlight, and part of that reflected light is captured by the sensor passively. Now, the sun is shining mostly in the visible and infrared parts of the spectrum, near-infrared, shortwave infrared parts of the spectrum. Therefore, this light is abundant during the day, barring clouds blocking the view, and the sensor doesn't really have to do anything except just look at the scene and record what it sees. So the radiation source is the sun, the objects are simply reflecting, and the sensor is just looking. It's passive. And this, of course, is in the visible, in near and shortwave infrared parts of the spectrum. And if we look back at our spectra, we've got visible and this part, the near and shortwave infrared part. Thermal infrared remote sensing is a bit different. Actually, it's quite a bit different in the sense that you can do this at nighttime even. Anything that has a temperature is radiating. And it's radiating usually, and the temperatures are common at Earth, in the long wave infrared. So what happens is, let's say during the day, the sun might illuminate the landscape. Those objects gather heat. Those objects become the source of light. Even if you can't see with your own eyes, it's still radiating. It's still giving out electromagnetic radiation. So the object is radiating, and the sensor itself is still passive. It's just looking in a wavelength that we can't see with our eyes, but if you had night vision goggles, you could see it, but not with your natural eyes. And it's about here, 10 micrometers. So right in here. So now the final one, and this is really interesting, is the microwave remote sensing. This is what we're really focusing on in the class. There are two types. The first one we're not going to deal with. This is the microwave radiation which is naturally occurring from the Earth's surface. And that's much like thermal. Objects are heated up during the day. They release radiation all the time. At nighttime, perhaps, it's easiest to see it. The object itself is doing the radiating. I should have mentioned one other thing with thermal, is that it doesn't have to be the source. The sun does not have to be the source of the radiation. You could be looking at plumes of warm or hot effluent in a river from a factory, or you could be looking at windows in a house, things like that. Anything that has a heat signature that can be seen. So microwave is very similar. It's just farther out, longer wavelengths in the electromagnetic spectrum. But finally, this one right here, this is the active sensing. This can happen any time of day. It doesn't matter what's happening on the ground. The sensor itself is the source of radiation. So like the ALOS-2 satellite with Pulsar-2, it's sending down a beam of microwave radiation. The objects under observation are reflecting part of that depending on their characteristics, and the sensor itself is seeing part of that that's coming back, the backscatter. We'll talk much more about this in the final videos of this module. And that's an active type of sensing, where the sensor is the one that's sending out the radiation and also collecting it. And that's happening way out here in microwave. So if we look out here, that's happening here. And of course, the advantage of microwave is that it can see through the clouds. It's not absorbed by the clouds. Okay? So these are three main types of remote sensing. Right? Types of sensors, active and passive. This is going to come up a lot in the course, but I thought it'd be interesting to provide you with this information right now. So what do we have so far? We've got this definition. I really suggest that you go through this a few times, try to figure out exactly what it means to you, but we're looking from above, we're using light, and it's either light from the sun, or light from the objects, or light from the sensor that we're using to see the things that we're trying to figure out what they are. And in this case, rice, or water in rice paddies.